make sure you have these written down. And then I'll tell you what will we do next week. So the work here you didn't need if you did this in Desmos, but you did need to graph it. You should have all of your points graphed. So positive 5, slope is negative 2, go down to right 1 as many times as possible, graph that line. The next page, some of you may have figured out, got help, looked it up. This is not something we talked about yet, but it is coming. To determine, is this a function? I'll explain it in general, but then we'll talk more about it later. It's looking for each of these have one x going to one y. So this one was a function, this one was not, that one was. And then on to the next page. Again, this is not something we've talked about yet. You're actually going to be talking a bit about domain range today and then some more later. But range is your y values, domain is your x values, so 5 was C, and 6 was D. And then 7C, these were all finding zeros. Those are your x-intercepts, your solutions. So you could put each and every one of these into Desmos and found those answers. So your zeros or x-intercepts for 7, 2, 0, I'll go down, 8, 4, 0, 9, 3, 0, and 5, 0, 10, 2, 0, 11, 6, 0, and 12, negative 2, 0. You could have also put those into Desmos, saw which one had 2 x-intercepts, and the only one that did that was C. And then again, 14 through the remaining, what are the zeros? If you put those into Desmos, you could write them one of 2 ways, either as the ordered pairs or in the set of curly brackets. You choose. But the zeros were negative 1/3 and 3/2. For 15, negative 1/2 and 2/3. For 16, negative 4/5 and positive 4/5. And then go on to that last page. D was x and y intercepts. So 17, you were looking for the x and y intercepts of this function. If you put that into Desmos, you would have seen that it's D. You could have also eliminated the answers by just looking at the y-intercept, because there was only one that had a positive 8. 18, you had to plot the x and y intercepts on the graph. 19, you had to put the 2 factors in that would create the graph given, which would be x minus 2 and x plus 3. We'll be talking more about that next week, how to find the factors to make x-intercepts. So the SOL sections that are due next week, this is the last time we're doing this, is the rest of the packet. 7E, 8, and 9. 7E is something we haven't talked about, so that one I want you to try, but that one won't be counted as the formative, but 8 and 9 will be, because that's direct inverse variation and line of best fit stuff. Okay, so keep that in mind. The rest of the packet is due next Monday. Does anyone need another copy of the notes before we start? in your notes. So Friday, we talked about how to find the axis of symmetry, the vertex, how to do a rough sketch of it. Now we're going to actually do that stuff again, talk about domain and range a little bit, and graph the actual function. So let's start with number 1. As a reminder, to find our axis of symmetry, that's our x equals negative b over 2a. So if we're using that here, negative b. If we were to use that formula here, we don't have a b, so what would our axis of symmetry be? How would I set that up first? Negative 0 over 2 times 1. And our axis of symmetry would just be x equals 0. So if I were to put 0 back into my equation, what would my y value be? Also 0. Which means my vertex is going to be 0, 0. You're going to put that in the middle of this table. And then the x column we can fill out. We want to go backwards 2 and forwards 2. So negative 1, negative 2, 1, 2. Now, with filling out your table and graphing, you can do this part in the calculator. You can do it by hand, in your head. That part doesn't really matter. So I could put each of these numbers back into my equation and then figure out what each of my y values are algebraically by hand. I could do that in the calculator individually. Put negative 1 in, put 1 in, put negative 2 in, put 2 in. Or I could go into y equals, go ahead and do that, and type in x squared. And then we're going to go into the table and find where your vertex was, find the other points we need to find, and fill out those numbers. So this would be the equivalent of you putting it in individually. So those values would be 1, 4, and 1 and 4. Usually they repeat. So remember that your axis of symmetry cuts your parabola in half. So whatever it is on one side, it should be the same on the other side, your y values anyway. So then we're going to plot these points. And you'll see it makes that U-shaped parabola. While Khalil, make sure you guys are writing this down. Draw that U shape. We don't need to draw in the axis of symmetry, but we could see because it's at 0, it's splitting it directly down the middle, and everything is symmetric. Questions so far on how we graph it? Okay. The domain, that's your x values. Range is y values. When we talk about the domain, we're looking left to right. When we talk about the range, we're looking lowest to highest, or bottom to top. So if I was looking at this graph, and I'm looking for the domain, I'm looking at the furthest point to the left, this keeps going left and up, off the graph, off the page, forever. Where would it start? So this is where it stops, or changes direction. But I'm trying to see, where would this arrow start from if it keeps going left and up? Negative infinity. Because this keeps going left, so it keeps going towards the negative x values. So it would start at negative infinity. If it keeps going to the right and it keeps going up, where would it end?
Infinity.
Positive infinity. For your quadratics, your domain is never going to change. It will always be negative infinity to positive infinity. Your range, however, will change. Questions about our domain first? I'm going to put another way to write this, and we'll talk more about this when we actually get into domain and range. But you may see it written like this. Curly bracket, x, is a vertical line. X, this is your E, and a double R. Curly brackets. This means x is an element of all real numbers. This is saying your x values are all your real numbers. Guys, stop talking, please. So you'll need to know both because you may see it one way or the other, but it's okay if you just write this. Range, lowest to highest. If it helps you, you could draw in a line where your lowest point is. What is that y value? 0. So it's going to start at 0, and because this is a closed point, I can say that this is included, so this needs a square bracket. Going back to our interval notation. What is our highest point? Where does this end? Infinity. Positive infinity, correct. Trying to see. So if I were to write this in, this is called set builder notation. I can say this starts at 0 and it's everything greater than 0, greater than or equal to. So that would be y is greater than or equal to 0. We're going to do a couple more of these. Do we have any questions on domain and range so far? Let's try number 2. So let's start with axis of symmetry. If you need to label your ABC, do that. How would I set up that formula? Negative 2 over 2 times 1. So our axis of symmetry is what? X equals negative 1. And then put that into all of your x values to find your y value. Make sure you're using parentheses. What would our y value be? That is a 1. It looks like a 7. Positive 4. So then our vertex would be negative 1, 4. Put that in the middle. So So depending on what our vertex is, our numbers are going to change. Go ahead and fill out the rest of your x's. Go backwards 2 and forwards 2. And we're going to put this equation into our y equals. And then go into your table and find your vertex. And then fill out the rest of the points. 5 and 8. Which means this is also 5 and 8. And then plot those points. What would our domain be? Correct. It's always the same. Negative infinity to positive infinity. I'm just going to put the other one just so we get in the habit of seeing it. Or x is an element of all numbers. Our range, this is facing up, so it's going to be something greater than or equal to. What's our lowest point? So this is the x and y, but what's our lowest y value? Just 4. So the vertex will help you find that if you can't see it on the graph, but you could also draw in a line at your vertex. So that means it's going to start at 4. It's included, square bracket. Where does it stop? Infinity. Or we could say that's everything greater than or equal to 4. On any of that. I'm going to try number 3. Any of you guys want to see on the next page and then move on? Okay. Let's find our axis of symmetry here. How would we set that up? It'd be a negative 8, or equals just positive 8 over 2 times negative 1. What would our axis of symmetry be? X equals negative 4. Yes. It would be positive 8 over negative 2. And then go ahead and put that into your equation to find your y value. Make sure you're using parentheses. What is our y value? We'll check that. Is that what you said? Okay, so our vertex is -4, -1. Go ahead and fill out the rest of the x values. Put that equation into your y equals. And then find our y values. You guys tell me what those are. Some of you are waiting for the answer instead of putting it into your calculator.
Where's the tape?
Second graph.
Oh, the first one is -5, -2, and after -1, -2.
So then graph those. -6, -5. -5, -2, -4, -1, and then it repeats. What's our domain here? Infinity to positive infinity. Even if it changes direction, it's still the same. Because this is going to keep going left and down, further and further slowly. And then this is going to keep going right and down. So it's going to keep going to both sides eventually. Our range, though, has flipped. What is our lowest point? These aren't lower than -1.
Oh, well then,
This isn't lower than -5. Negative infinity. That's where it starts. And then what's the highest point? -1. And that would be your bracket. So whatever that y value is always going to be somewhere in your range. You just have to know if it's going to be the first or the last, depending on if it's facing up or down. I'm going to write in the other ones. I'm going to write them down here for the rest. So this would be everything below -1, so less than or equal to. Are there any we want to see go over really quickly on the next page? Then go to this page really quickly, and this is the last thing we do today. So now we have the graphs already. We're just comparing. We don't have the equation, but we can still find this information from just looking at the graph. What is the axis of symmetry of graph A? Where would it split it down the middle? -2. So this would just be at x equals -2 if you want to draw a line there. It's a really big dash line, but x equals 3. What is the vertex of graph A? So your vertex is your lowest or highest point, and it falls on the axis of symmetry. Say that again. -2, -5 for graph A. What about for graph B? We'll answer those questions in a second. 3, 4. Remember that maximum is your highest, minimum is your lowest. Is the vertex for graph A a minimum or a maximum? Minimum. For graph B, is it max or min? Max. The domain for both of these is going to be what? Negative infinity to positive infinity. But the range is going to be different. So the range of A, graph A, that's lowest to highest, where does that start? Where does that end? -5, your y value starts at -5. Where does it end? Infinity. What about graph B? Where does that start? Where does that end? Is the start or the end? The end. It starts at not positive infinity, but negative infinity. Right? And then for 7 and 8, it's just now identifying what the equation is. So for 7, we know this is facing up. So we can eliminate which two? C and D, because those have a negative A value, those would face down. Then you could graph one of them, see if it matches, or pick a point and put it into all the x's and see if it's the same. So let's graph A. And I'm just going to look at the graph. Does this look like graph A? No, so then it's B. Right, same thing for graph B. This one faces down, so which two could we eliminate? A and B. Which one do we think this might be? Okay, so let's graph C. Is that? No. So we have 50-50. Those are. So you need to be able to not only find them from the equation, but find all of this stuff from the graph as well. So when you do the delta map for this goes back to being informative. This one is due this week on Friday. So make sure you're working through that, even though it's informative, so that you practice this. Remember, we're still testing this unit.